All right, doing this problem called merge k sorted lists. I'm going through this blind 75 list, and this is one of the questions in that list. And there is a previous question that I solved, which was merged two sorted lists. I'm guessing this is just an extension of that. It's marked as hard though. Let us see. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all linked lists into one sorted linked list and return the list. 145, 134, 26, 1123, 44, 556. The linked lists are this, and this, and you merge them into one sorted list. Now, this is basically how do we sort? So, for the first position, what are all the candidates? The heads of all the lists are the candidates, right? So we compare all the heads of all the lists, and whichever is the smallest one is the is my final head. Then whichever list I pick. Uh, so what I mean by that is there are n candidates, right? So had one, let's call three lists, had two and had three. And whichever is the smallest, let's say had two is the smallest, right? So head two becomes the head of the list, and then this guy's this list will update its candidate to head two dot next, right? And now these three are the candidates, and whichever is the smaller, you take that and give and you update the candidate from that list. Essentially, that's all, right? So, and how do you sort? How do you find out the smallest guy? So there are n lists. Why don't we keep like a priority queue of size k, right? If or n, then priority queue of size n, right? So we are given an array of linked lists, and the list can also be empty. So basically, the head can also be null. And we wouldn't want to save null. It's as simple as that. Like I don't want to save null. So I want to keep the all the things in priority queue, right? So we start priority queue of list node. Call it queue equals to new priority queue, and I'm assuming I'm never add null into the priority queue. So I'm defining my constructor as a comma b will have to be a dot val minus b, not the constructor, the comparator. So now I add the value into priority queue. So for each list, so I go to all the lists. So for each list in lists, I will do if list is not equal to null, then add it into my priority queue. Okay, and now when I pull from the priority queue, I'll get the minimum one out. So while the priority queue is not empty, now here let's also define your head as null. While priority queue is not empty, you remove one element from the priority queue, and if your head is null, then you assign this guy as your um, node, right? And then, sorry, a head as node. I'm tempted to check uh, something, uh, which is what is okay. We can search. So priority queue top element. Is there a Java docs? And is there a peak? Does it support peak? Yeah, okay. Peak is something it supports. So it was peak. Um, so what I want to do is this. I don't want to keep this if inside. Just okay. So if your priority queue dot is empty, if it's not, they want to do this if check only once, not inside all. This small minor thing. If the priority queue is not empty, then head equals to priority queue dot peak. I want to remove this if condition from here. Okay, and now I get the node out. I'm thinking now, should I always have kept like the first guys out, or uh, let's take. Okay, so then we do this instead. So a last we maintain a last node as also, uh, or a current node, whatever. So current equals to head. Maybe it's remove one. Maybe it's remove the first guy, right? So you get the head of the linked list. Nah. Okay, let's do this. Let's create a dummy node and or rather just the uh, and mark current as dummy. How about that? Right? Does it support a Unix node? Yeah, it supports, right? Now what I do is I get this node out. Now simply whatever is my current node is, current's next is going to be this node. As simple as that. Right? So the current node is going to be this node, and in the priority queue, if node.next is not equal to null, then priority queue just add node.next. So you're going through all elements, you're going through priority queue, you get the smallest one. I think this works. Now at the end, I'll keep updating my current.next, current.next, current.next. But wait, I think there's a miss here. So current.next is node, but you also have to then do current equals to node or current equals to, yeah, and then current also equals to node. So that's fair. So you created a dummy node. That dummy node's next is the first small node. So the and you have to return dummy dot next. Yeah, works for me. So let's see if the solution works or not. First of all, illegal start of type. Why? While is it a space or what? Is priority? Oh, it's called queue. Let's call it priority queue here. Let's call it priority queue. Okay, run code. Illegal start of type. I don't really. Let's see. Line 28, line 37. Identifier expected. Val and next is fair. A dot val, b dot val is fair. Is it like you came too much out? Okay, so this and then okay, run code. Spelling mistake is fine. Okay, submit. And it works. Yeah, so it was the same. The point is the same, which is at any point in time you have at max n candidates, and out of those n candidates you take one, which is the smallest, and from whichever list you take the smallest, you upgrade its candidate if it has any more candidate, and then again choose next and choose next and choose next and so on. All right.